Almost done with these castings now, going really well. Just formality here, one last check on this. Oh, that's not good. Hello Internet, my name is Quinn, and this is Blondihacks. Today's the day I'm going to start work on the cylinders for my Pennsylvania A3 switcher locomotive. These are obviously very characteristic, very charismatic parts for any steam locomotive, so let's see how good we can make them right now. We've made good progress on the running gear, but we can't really continue until we have something to attach it to up here. So that means it's time to start on the cylinders. Kozo has an elaborate series of operations, fixtures, etc. for making the cylinders out of bar stock. As is typical of Kozo, one of the signatures of his locomotives is that he uses no castings, except the drivers for the A3. It's a bit of an exception. However, we are going to use none of this, because I have castings for these cylinders. Companies that make drivers for the A3 also make these cylinder castings, and a viewer donated these to the channel a while back, so I'm going to try using them. Castings are nice because they let you start with a shape that's closer to the final thing you want, and so you have less machining time, in principle. So these guys are going to be finished, and we'll go here like so, and give us something to attach all of the running gear to. These castings are a little bit rough around the edges, literally. These are not the best ones I've seen. In particular, the round section is definitely a little bit wobbly in shape, and it's quite a bit oversized. I suspect that the molds that are being used are probably worn. There's a lot of evidence of that. However, the good news is this thing is way over dimension on every dimension that I can find. So that's a double-edged sword. It means there's a lot of machining to do, but it means that setup of this casting is going to be extremely forgiving because we don't really have to worry about alignment causing us to lose the ability to clean up any surfaces. You can pretty much stick this thing in the machine blind and it's going to clean up because we have a good 200 thou or even more in a few places to remove from pretty much every dimension on this thing. So I think if nothing else, I don't know if it's really going to save time over bar stock, honestly, but if nothing else, it's a big piece of bronze that I would have to buy anyway. So I'm going to try using these and see how it goes. I'm going to make the bore first, and I'm going to use that as my reference for all other features. That's different than what Kozo does in the book because when starting with bar stock, Kozo can create outer reference surfaces quite easily. However, with a casting, you need to generally start with inner features because you're going to be leaving cast surfaces unfinished, so outer surfaces can't be used as reference. I'm dialing this in based on the rough casting surface, which of course is going to be very approximate, especially on this casting, which as I said is pretty out of round. However, you have to start somewhere with a casting, and the goal here is just to try to get the bore as well centered through the middle of the casting as possible, so that all the other surfaces around that bore will likely clean up well. Because this casting is so rough, you're not going to be able to get it concentric, so you can do what's called four-pointing, which is where you dial in one axis of the forejaw at a time as best you can, and then do the other axis. So one axis might be dialed in to within 5 thousandths, the other axis might be only, say, 20 thousandths, but on average then, you'll get a pretty reasonable centering of the casting. That method saves you a lot of chasing your tail trying to dial in something that's misshapen or really rough like this. Quick spin up to do an ichrometer check, and yeah, that actually looks pretty good. Considering how rough this casting is, that's running reasonably true. And as I said, there is so much material to remove off of this thing that's going to be more than well set up to machine this thing down. So I'm going to start by, of course, facing down the end, as is tradition. This casting is actually a good 1/2 inch over length, so I'm machining roughly 1/4 of an inch off each end in order to get the thing down to final length. I'm going to do them one end at a time, of course, so for now I'm just machining roughly half of the material that I know needs to come off of this end, and then I'll bring it to final dimension once we get around to doing the far end of this casting. As you can see, I'm not even there yet, and I'm starting to run into what is the steam chest casting, but that's okay, we'll just machine that down as well. We were going to have to face the side of that steam chest area anyway, so I'll just keep right on going until I get to the overall width of the cylinder, and we're going to be facing the side of the steam chest at the same time. Once this end is where I want it on the round part of the casting, then I can continue machining just the steam chest side, because the steam chest is supposed to be a little narrower than the cylindrical part of the casting. So I'll create the little step here by continuing to machine, effectively creating a shoulder where the steam chest and the cylinder part of the casting meet up. Once I've got that faced to depth, that step now is the correct depth, I can do the final step, which is to machine down the cylindrical portion to the final diameter, which again is quite a bit smaller than the casting. One thing you'll notice once this diameter is finished is that the diameter of this end is going to be quite a bit smaller than the round part of the casting that's under the steam chest. Now that's different than what the drawing specifies. This cylindrical portion is supposed to be the same diameter all the way through the casting. I'll tell you what we're going to do about that later. For now, however, let's get on to this bore. Now that bore is very rough. The idea is you should be able to just put a drill in there to start with. That's why they put a hole in the casting. However, that one is so rough that even a drill is not going to track very well at all. It's probably going to be hard on my tailstock to try and put a drill in that. So instead I'm going to come in with a boring bar and true up this bore to start with. Cast bores are done with what's called a sand core. It's literally a piece of packed casting sand that's suspended in space in the middle of the casting, allowing the metal to kind of flow around it. And it allows you to create a negative space inside a casting like this, which speeds up manufacture and saves on materials. However, as you might imagine from that description, it's a very imprecise process. So cast bores can never be trusted for anything at all. But now that that has been cleaned up with the boring bar, I can now go in with some big drills because we have a lot of material to remove, and doing it all with the boring bar would take quite a long time. You'll see those drills wobbling around a little bit, even though the bore that they went into was concentric, and that's because right as it started cutting, one of the flutes caught an edge a little funny and started cutting off center and continued doing so. That's why you just can't trust drills for very much. But that's okay, we're just doing bulk material removal here, which is what drills are good at, and I'll leave myself plenty of room to clean up to final dimension with a boring bar once again. In addition to speed, the other reason to do as much of a bore as you can with drills is because then your starting bore for the boring bar is much larger, and what means you can use a much beefier boring bar that's going to be more rigid, have less deflection, less chance of chatter, and so on. Boring bars are extremely floppy things to begin with, so you absolutely want to use the absolute biggest one that you can at all times, just to give you a fighting chance of having a decent surface finish and a chance of hitting that dimension. I think this is actually my largest boring bar. This is a Shrum Solutions solid carbide boring bar. Really beautiful thing. I don't often get to use one this big in my tiny machining world. And by this big, I mean smaller than the absolute smallest one that Cutting Edge Engineering owns. I will say that while the geometry of this casting is pretty rough, the metallurgy of it is beautiful. This bronze is a really nice alloy. It's machining beautifully, no inclusions, no chilled spots. Really, really nice quality casting in that regard. So using my telescoping bore gauge then to sneak up on the final dimension that we're shooting for. This is a 7/8 bore. That's the piston bore of the A3 locomotive in 3.5 inch gauge. Plenty of piston bore for pushing you and a few of your friends around the track. Steam is powerful stuff. You don't need much displacement. When doing cylinder castings, I always like to mark the end that was faced in the same setup as the bore was done, because that end is going to be perfectly square. So that's the end that you want to run the piston rod through, that head. The other end, the head is blank and doesn't really have to be that square. And the other end is never going to be quite as square as this one, no matter how carefully you do it, because it's always going to involve a second setup and trying to indicate in the bore or some other reference feature to get as square as you can. I've brought both castings to this point now. You can see that the castings are handed. Now, to face that other end, the probably best way would be to just clamp it down on the mill table like this and machine it flat. I don't have a good way to hold it square in the lathe from this side, so I thought about doing this because this will get me as parallel as possible to the other face. However, there's not a lot to clamp on here, and this would be a lot of musical clamps to try and machine that down, and I have a lot of material to remove for this. So instead, I decided to try something stupid. Let's see what happens if I just put this casting in the vise. I'll set that good reference face down on the bed of the vise, and I'm going to clamp it in the vise and see what happens. Now this is violating all good rules of vise setup. I've got rough surfaces on both vise jaws, and I've got a lot of over constraints and competing angles on those vise jaws. But let's just put a dial indicator on this thing and see if it moves when I clamp it, because maybe it won't this time. And if it doesn't, this is a huge win. And look at that. I clamped that thing down, and it did not move at all. So, sometimes you get away with the wrong thing anyway, as long as you know why it's wrong and you can check if you're getting away with it. In fact, I didn't quite believe I was getting away with this, so I shone some light down there to check for gaps underneath the part, and it looked really good. This looks like it's going to be a parallel cut, so I just dug out the face mill and went for it. It's okay to break the rules sometimes, as long as you learn the rules first and learn why they're rules. Then, when you try to break them, you know what to check for to make sure you're getting away with breaking those rules and possibly save yourself some time. Facing the far end of this casting was going to be difficult because, as I said, there's no really good way to hang on to it. And one other way to do this would be an expanding mandrel inside the bore. It's kind of honestly probably the only way to hold it in the lathe that would allow me to face this other end perfectly square, referencing the bore, which is what we need to do. So I decided to do it this way. Not very elegant, but as I said, I think I got away with this. Or did I? As I was approaching final length on this, I've got about 20 thou left for finishing cut. I wanted to double check and make sure that I really did get away with that. So I put it on the discount surface plate, that is the top of my vise, and ran it around, and yeah, look at that. I did not get away with that. One corner is all zeros, the other two corners are 1.5 and 2.5 thou low. So what happened? Why didn't my little test work? Well, foolishly, I measured only on this front top edge of the casting because I figured if there's going to be jaw lift from the vise, that's where it's going to be most measurable, and jaw lift was really the only thing I figured could go wrong with attempting this setup. That was not correct. What happened, in fact, if you look where the low spot is on the casting, the other side of the casting tilted upward towards the cutter when it got clamped. So it tilted in a way that wasn't detected by my measurement. I really should have checked 4 places on the top of this casting, or at least 2 places, one on each axis, to see if it was moving in any direction. It never occurred to me that it might move in some direction other than the one direction that parts generally move due to jaw lift in a vise. Fortunately, at least, I knew enough to know that there's no way I should be getting away with this, and so I checked it before my finishing cut, so I still had plenty of material to remove to correct this error, and then I set it up in the other way that I mentioned, which was inconvenient, but now I only have to take one cut, so I only have to play musical clamps once. And in fact, when I went to do the other casting, I actually did it the same way because the janky vise setup was a very quick way to remove a whole bunch of material that I needed to remove to get down to this finishing cut, and then once again went to this face setup on the table for the final cut. Next, then, I need a mandrel for the next series of operations, so I got a piece of steel from the scrap bin, and let's turn this down. I've got a whole bunch of other features to do on these castings, and I want them all to reference the bore, and the easiest way to do that is to just hold the casting with the bore. That'll make it really easy to do rotations of the part and indicate on the part and so on, because I'm always holding it from the reference surface. I've turned a couple of different diameters on this, a large diameter at one end that can go in a collet, so that's a standard diameter, then the diameter in the middle, which is very accurately turned to be a very, very close fit inside the bore for an accurate reference, and then I'm turning a clamping thread down on the end of this mandrel. I've also got a center in the end of that mandrel that will stick through the clamping nut and allow me to do more operations on the lathe later with tail support. So a surprising amount of thought went into this mandrel, and this was, a non-trivial amount of work to make this, but I'm going to get a whole ton of use out of this thing, so it was definitely worth the time to do this. And even though this mandrel is never going to be used for anything other than these 2-cylinder castings, it's really not a waste of material because, as you can see, 90% of that bar I started with is still here. So when I'm done with this mandrel, it goes back in the bin and it'll get made into something else some other day. And Yahtzee! The first job for this mandrel then is to go back in the 4-jaw chuck so that I can do some lathe work on the other ends of these castings. A person could have just left the mandrel not parted off of the stock for this first couple of operations since it was already in the lathe and perfectly concentric having just been cut, but it's alright. I was going to use this mandrel for some other things, so I parted it off and then decided to come back and do the lathe work first, so here we are. Now, in addition to dialing it in concentrically, I'm also checking if it's straight, and of course it's never going to be quite perfectly straight, especially when using copper soft jaws like that. They tend to affect the alignment of the part a little bit in the jaws. Because this mandrel is fairly long, it's easy for the inside of it to be concentric, but the outside to have run out or vice versa. So you got to go back and forth, tapping in the far end concentric and then dialing in the near end concentric until everything is concentric and straight. Now I'll be able to clamp my cylinder castings on there like so. There's just enough of a shoulder on the far side of that mandrel to clamp against. The bolt is not tightening against the vice jaws or something else, which wouldn't work. That would just pull the mandrel out of the jaws. Got to have a shoulder to clamp against. And that is looking pretty good. I think that's going to run nicely. Of course, there's some eccentric mass on that, so it is going to vibrate a little bit in the lathe, but as long as I keep the RPM in a safe zone, then it's going to be fine. So from here, I'm doing the same operations that you saw me do on the other setup, which is to say facing down the side of the steam chest. The overall length is already correct, of course, so I don't need to redo that part of this, but I need to face down that steam chest side to get the step distance correct. And the good news is the overall width of the steam chest came out perfect within 1,000th. So I did something right in my overall assessment of this casting. And then I again turn that diameter down to the correct final dimension to create the little step next to the steam chest. These little step diameters on the ends have cylinder covers that go on them to cover the cylinder heads. It's a decorative feature that was common on locomotives. The cylinder heads had a bunch of bolts and stuff on them that the company folks didn't like. Makes the locomotive look nicer to cover all that up. So there is one cylinder casting done on both ends. So I brought both castings to this point. I mentioned earlier about the extra diameter in the casting there that's sticking out past where it's supposed to be. That diameter, of course, can't be turned on the lathe because of the steam chest is in the way. So what's going to happen here is I'm going to have to remove that material with a shaper operation, which would have been necessary on the bar stock version of these cylinders anyway. So you'll get to see me do that later on. But for now, I'm going to take the castings over to the milling machine and I'm going to do the steam chest features. Once again, the datum for all of these features is the center line of that bore. So the nice thing about this mandrel is that I can get my reference from it before starting the cutting. Using a feeler gauge to find the top surface of that mandrel, and then edge finding on the y-axis to get the center that way, I can now get my casting in here, and the quill DRO is set, calibrated if you will, to the height off the center line of that mandrel. So with the first casting in here now, I'm going to try to get it as straight as I can. There's going to be draft angle and other artifacts in here, so it's definitely a best effort kind of situation. But I did actually manage to get this guy straight to within 20 thousandths. That will be plenty, again, because there's a ton of material to remove off of this dimension, just like all the other dimensions on these castings. So I'm not too worried about it. As long as we're in the ballpark on straightness, then this will all clean up nicely. So this all gets machined down to a specific height above the center line of the bore, as given in the drawings. I'm using a smaller end mill this time instead of the big face mill because I'm going to be doing some other features that require a smaller end mill. So I want to be able to have a single reference for all of these cuts and not have to refine surfaces or redo math, because I don't want to remove the part from the mandrel. So I only get one chance to find that center line reference that I talked about. So that top surface is the port face where the steam chest is going to be sitting. It's going to have all the ports in it for the valve. Then there's a little step feature outboard of this where it connects to the manifold face. And again, this is why I use the small end mill, because I can create that feature in the same setup. Everything's going to be perfectly parallel, square, on dimension, etc. with no indicating. Very easy. Now the really cool thing about this mandrel and the collet block is now I can just rotate the collet block 90 degrees and create the manifold face features. And this is going to be perfectly 90 degrees to the steam port face, and everything's just going to line up. Again, no indicating, measuring, or anything. Furthermore, because the collet block rotates around the center line of the mandrel, this means that my vertical reference is still valid for this feature. So I can just cut right down to the same numbers as specified in the drawing on the DRO. I don't have to find the height off center for this feature after we rotated it. This order of operations is different than what Kozo specifies in the book, but this worked out really well for me. A little bit more needs to come off the width of that manifold face, because again, it's rough cast still on this edge. So I did a little bit of side milling to remove that and bring that down to dimension. And remember, we're going to be removing the rest of that cast material later in a different shaper operation. That all went just fine. Now, however, I need to do the same cut on the steam port face, because of course it needs to have a machined side as well to line up nicely with the steam chest and bring that down to final dimension. However, now we've hit a problem. This dimension is already undersize. Amazingly, this casting, which has enormous excess material on every dimension, somehow did not have enough extra material on this specific dimension. At this point, I have a dilemma. Now, I have to machine that face if I'm going to use these castings, so either I end up with this dimension being undersize, or I scrap the parts and start over with bar stock. what I decided to do was try to clean up this face and see where I land. So I took the lightest possible cut that I could to try and clean up this face. I still ended up with a little bit of wisps of casting surface there, but that'll get covered by powder coat anyway. And let's just see where we actually landed. Survey says 1 inch 74 thousandths, which as it turns out is exactly 20 thousandths under dimension. Now the question is that still within tolerance? This gets us to the interesting thing about Kozo's drawings. Kozo's drawings are not full-blown engineering prints. They're kind of casual drawings, if you will. So one of the things that they're missing is they don't have a proper legend box which explains all of the unspecified tolerances. Kozo uses a lot of fractional dimensions, which could be a sign that the tolerance on these is being specified in the traditional way. Kozo uses decimal numbers when the tolerances are really critical, such as on these port faces. Traditionally, in imperial machining, this goes back 100 years, fractional dimensions on drawings imply a tolerance of plus or minus 1/64th, which is 16 thousandths. Now, Kozo does not actually say in the book anywhere that that is what he is doing. And this is a very old convention, so it would be a little odd if he was using that convention. But on the other hand, I don't know why else he'd be using fractions everywhere when he uses decimals in the areas where it really counts, especially using a lot of weird fractions like 27/32, which even in modern imperial machining, nobody does that anymore. And as I said, if these were formal engineering prints, there would be a legend box that explains, hey, for every dimension that doesn't have a tolerance specified on the drawing, this is the tolerance. In modern imperial machining, which I know sounds like an oxymoron, the standard technique is to use multiple decimal places to specify tolerance unless otherwise specified. So if the dimension has 2 decimal places on it, that's an implied tolerance of 10 thousandths. Or if it has 1 decimal place, that's an implied tolerance of 100 thousandths, and so on. So interestingly, Kozo actually does that too in a few places. He's got some decimal dimensions that are specified with only 2 decimal places. So again, this would all be cleared up with a proper legend box or even a foreword at the beginning of the book saying, hey, this is how I'm specifying tolerances in my drawings. Unfortunately, Kozo doesn't do that, so we're kind of left to guess here. If we go with the traditional imperial interpretation and say that all of these fractional dimensions are plus or minus 1/64th, then that gives us hope because the 5/8 dimension up here is the one that we've blown. So in principle, though, we're then actually only 4 thou outside the tolerance on that dimension. And we could easily modify the mating part, which is the steam chest body, to line up with that. We could shave a few thousandths off of that part and still be within tolerance on that part and have it line up with this part. Now, that is actually altering the volume of the steam chest a little bit, which could affect performance of the locomotive a little bit, but we could also easily compensate for that with massaging a little bit more off the interior of the steam chest. I looked ahead in the book, there's plenty of extra material on the steam chest where we could make some of these changes. So those are basically my choices right now. Modify the steam chest while still trying to keep it within tolerance to line up properly with the cylinder casting that we have, or start over with bar stock and make these things all over again. I even actually bought the piece of bar stock to do this just in case I decide to go that route. I had to special order this. And well, this is about $150 worth of bronze round bar right here, but I ordered it anyway because I am going to need this later in the locomotive. So if I don't end up using it for these cylinders, then it will get used on this project. Not a problem there. However, I don't want to use it here if I don't have to because it is a lot of material and a lot of cost and a lot of time to redo these. So I'm going to leave this here while I think about it. I'm not actually sure what I'm going to do. Right now I'm leaning towards saving these castings by making some small tweaks to the steam chest, but I haven't decided for sure yet. I guess you'll just have to stay tuned next time to find out what I decide to do with this. And in the meantime, thank you very much for watching. Thank you very much to my patrons for making all of this content happen every single week, and I will see you next time.